Hello there, Wildcats. In this video, we'll evaluate linear function, we'll graph linear function, and we will write an equation of linear function, and of course, we'll be applying linear function by solving word problem. So first is we are going to evaluate linear function. So on your screen right now, the question is, what is the value of f negative 3 for each function? Okay, so as you can see, or if you are going to connect the these equations into your slope intercept form, yeah, they are look alike. But the thing is, we are now talking about functions in here. Okay, so we use f of x to represent function, and then the value, okay, the number inside your parenthesis, meaning that's the value of x, meaning f of negative 3. Okay, negative 3 is the value of x, and f of x in your slope intercept form, that is your y. Okay, so let's start with the first number. So we have f of x is equal to 4x minus 3 minus 9. So as what I have said, you have f of negative 3. You see your x is negative 3, that is equal to 4. Now instead of putting x, we have to plug in negative 3 in here, minus 9, and then you have to evaluate that. So we have this is negative 12, okay, minus 9. Therefore, this will be, so because both are negative, this will be 21, and it's negative. So f of negative 3 in this function will be negative 21. Right? Now, if you will interpret this, okay, if you will interpret that, it says there that the value of x is negative 3. So if I'm going to put this one in an ordered pair, the value of x is negative 3. What would be the value of y? The value of y will be 21. Okay? Next, number 2. The same value of x, and then the function will be negative 1/3 x, negative 1/3 x plus 13. So again, we have to put the value of x there. So negative 1/3 times negative 3 plus 13. So what will we do here is f of negative 3, that is positive 1, okay, plus 13. So f of negative 3 is equal to 14. Okay, so because 1/3, negative 1/3 times negative 3, that's 1. Okay, and then we add that to 13. So f of negative 3 is 14. So if I'm going to interpret that, so the value of y when x is negative 3 is 14. Easy. Okay, number 3. F of x is equal to negative 2x minus 11. Again, the same value of x, which is negative 3. So f of negative 3 is equal now to negative 2 times negative 3 minus 11. This will be positive 6 minus 11, positive 6 minus 11. So f of negative 3 will be negative 5. So we have negative 3, negative 5. So based on the previous video that I made, okay, so we discuss your domain and the range. You have your input and output, and we have the dependent and dependent variables. So in this case, your domain and your input, it's negative 3. Okay, now your output, which is your range, is negative 21, 14, and negative 5. Okay, next is we are going to graph a linear function. So draw the graph of each linear function. The same way when we graph your slope-intercept form, okay, still we'll be using your slope and we'll be using your y-intercept. Okay, so in here, your y-intercept will be your slope m is equal to 3, and our y-intercept will be 0, negative 6. So first you have to graph 0, negative 6. It's here. And then we have 3 up, 1, 2, 3, 1. Because this is there is a 1, invisible 1. All right. So I'll just combine that, or just draw a line. Sorry about that. I'll be using blue. And then I'll be using solid here, solid line. I'll just make it that it's connect here. There you go. I did connect them. So this is now the graph of the function 3x minus 6. All right, next one is we have the function of x is negative 2, and then we have x plus 4. Okay. All right, for example number 5, as you can see, there is a parenthesis there. So the scale factor of this linear function is negative 2. So your slope there will be negative 2. Okay, so our slope here is negative 2. And then our y-intercept will be 0, negative 8. Okay, because if you are going to check that and do the distributive property, it will give you negative 2x minus 8. All right, so first graph your our y-intercept, which is 0, negative 8. It's here. And then we go to the left of it. So 1, 2, 1. And then, so this is our graph. So I'll just connect them using green colors here. So this is now the graph of the function 2x. I'll just make it realistic here that this one are points are connecting. There you go. So the function, that is the graph of the function negative 2 the quantity x plus 4. Right. Next is we have number 6, which is f of x is equal to 1/2 x plus 5. So identify the slope. The slope is 1/2 positive, and then the y-intercept is at 0, 5. First is graph your 0, 5. It's here, and then it's here 0, 5, and then we go up once, 1, and then 1, 2. Okay, and then connect these points. All right, so we're done graphing it. So that is how you graph. Again, on graphing linear function, it's the same when we graph your slope-intercept form in a linear equation. Okay, so you have to identify your slope and then the y-intercept. And for number 5, as you can see on that, will be on the next topic that we have. I will explain it further to you guys, the linear function translation as we go on. Right, next one is we are going to write now an equation. So we're going to interpret a given table, and then we will write an equation based on the information given to us. All right, so use the data in each table to write a linear function using function notation. Again, your function notation will be f of x or g of x or any letter that you want, m of x. So as long as it's the function notation that we have there. So first is we have the value of x and the y, which is -5. So these are your input, these are your domain. Okay, just a review. This is your domain, which is the values of x, and the values of y are your ranges. Okay, step one is we have to solve for the slope. Okay, that's the first step here. I'll just put 1. Solve for m, which is m is equal to y2 minus y1 over the change in x. You can choose any of the point. So I'll be using maybe the first 2 point, which is -5, 10, -2, -1. So m, y2 is -1 minus -10 over x2, which is -2 minus -5. I'll just simplify this further. That will give me -1 plus 10, that is 9, right? Over 5 minus 2, it's 3. So my slope here would be 3. So that was my slope. And of course, after solving for slope, we have to solve for your y-intercept, or the value of b. Now the value of b is that we have the function of x, okay, is equal to the slope, which is 3x, plus b. I'll just put there b. Now it's our problem. How are we going to get on b? The same process, the way we do it on your slope-intercept form, is that we have to choose any of the point. So maybe I'll be using the first point, which is -5, -10. So I'm going to use this. Maybe I'll just write this one into a green one, -5, -10. Sorry about that. -5, -5, -10. Okay, that will be our point, and this is our x, and this is our y. Okay, so I'm going to use this equation and use this point to find for the value of b. So my f of x, which is your y in your slope-intercept form. So it says there, if x is -5, what will be the function? So it's -10. So I'll put there -10, okay, is equal to 3 times -5 plus b. So we are looking for the value of b. Thus, we will be doing is, this is 15, all right? So -10 is equal to -15 plus b. So I'm going to add 15 both sides. Add 15. This one will be cancelled. So the value of b now is equal to 5. So, but on the problem, it says there we have to use this data in this table to write the linear function using the function notation. So our final answer would be f of x, okay, is equal to the slope, which is 3x, and then plus 5. This is now the function. All right, there you go. This is now the function. Okay, next one. Again, we'll be using this table, the same process. So what are we going to do is find the slope first. So m, so I'll just put a fence here. Ooh. And then I'll be using green color. Step 1 is find the slope. You can choose any 2 points. So I'm going to first to use the first 2 points. So 2 minus 8 over -2 minus -5. That's 2 minus 8 is -6 over, okay? This will be -2 minus -5. Double negative will give you positive, so 5 minus 2, which is +3. So the slope is equal to -2, right? And to find the value of b, so f of x is equal to -2 as our slope x, and then plus b. This is b, okay, not 6. I can choose any of the point here, so I'll be using, maybe I'll use red color. I'll be using the first point, -5a. Okay, so what I'm going to do is -5 f of -5, which is not f of -5. So instead of f, the whole function, if x is -5, the whole function is 8. That's what it says there. So 8 is equal to -2, and then x is -5 plus b. Okay, so we have 8 is equal to +10 plus b. And then I'm going to subtract on both sides. That will give me b is equal to -2. Alright, so b is -2, and our problem, it says that we have to use the data, the table, to write a linear function using function notation. So our final answer is that f of x is equal now to the slope, which is -2x. The slope is -2, then you put the x there, and then your b is -2, so -2. So this is your final answer. All right, next example is we're going to use our knowledge now on linear function to solve word problem. I'll just move this one a little bit. There you go. So you can see the problem. So a function f of x is equal to 4x plus 5 has a domain of x is greater than or equal to 0, but less than or equal to 50. So what is the range? So if we are going to interpret this, okay, so I'll just write here, your domain is, it says there, it is x is greater than or equal to 0, but x is less than or equal to 50. So you have to focus on the 0 and the 50. So what will be our range? Okay, what is our range? So you have your 0 as the minimum, okay, and 50 as your maximum. Okay, 0 is the minimum domain, and then the value of x there, the value of y will be your minimum also in your range. And then when you put plug in 50 as the value of x, that will be your maximum on your domain, and it will be maximum on your range also. So if x is equal to 0, okay, so if x is equal to 0, that will be f of 0 is equal to 4 times 0 plus 5. All right, so f of 0 is equal to, of course, this will be cancelled out. It will be give you 0. So f of 0 is 5. So meaning the range here, okay, the domain is 0, which is x. So the range here is 5. So you have a 0.05. And this is also will be your y-intercept. Okay, so in this situation, the minimum range will be 5. Okay, so I'll highlight that. Okay, this will be your minimum. Now your maximum is 50. If x is equal to 50, so what will happen? So I have f of 50, sorry about my writing there, f of 50. So f of 50 is equal to 4 times 50 plus 5. Okay, so your f of 50, which is f of 50 is equal to, that's 200 plus 5, that's 205. So your range here will be 205. And the point is 50 and 200. Thus, we have the minimum domain, which is 0. When the domain is 0, the range is 5. And we also have the maximum. The domain is 50, and we get 205 as the range. So your range here is that your y would be, okay, I'll be using y as the range, and then I'll use blue. Y must be greater than or equal to 5 as a range, but less than or equal to 205. So all of the domain in between will have one range that we have there. Okay, and the last example on the word problem is that for a basic subscription, a cable television provider charges an activation fee of 60 plus 100, an activation fee of 60 and an additional 150 per month. What linear function represent the total cost? Okay, so we are going to write a linear function that will represent the total cost of the basic cable subscription for a month. And then what is the total cost for 2 years? Okay, so for 2 years, so what are we going to do now is we have to set first question. So f of x is equal now to, is going to pay 125 per month, and we do not know how many months he's going to pay for that. So it's 125 x, or t. We'll be using t, months. So t, and then your y-intercept will be plus 60, because this is the upfront payment. Okay, it's the activation fee. So this is now our linear function that will represent the total cost of the basic cable and subscription for the T month. It will vary how many months is getting. So it will be depending on how many months. On the total payment will be dependent on how many months you're getting from there. So the second question is, what is the total cost for 2 years? Wow. So it's 2 years, and the computation is on months. So 2 years is equivalent to how many months? It's in a year we have 12, so 2 years, that's 24 months, right? So it's 24 months. So we'll just put there f of 24. I'm sorry, I have to change that. This is not x. That would be t. F of t. Green tea. So f of t. So f is equal to 24 is equal to 125 times 24 plus 60. So f of 24 now is equal to 125 times 24, that is 3,000 plus 60. So in 24 months, you will be paying 3,060. So this is our answer for 24 months. Okay, so we interpret that for 24 months, the total cost, sorry about that, for 24 months, the total cost will be $3,060. Right, there you go, guys, about linear function. So, and again, as a review, what we did today on this video is we evaluate linear function, we graph linear function, and then we write a linear function based on a given given graph or given given data, and the last one is we use linear function to solve word problems. We'll see you in our next video, guys. Bye bye.